We are almost done with chapter 13 and we are continuing with polygons, the geometry stuff. So last time we talked about the linear measure, right? And the last thing that we did was perimeter. A lot of times students are confused about the perimeter and the area, right? So what is the definition of a perimeter? Peri means around, meter, the measurement. So perimeter is measuring the length around the shape, right? If it is a circle, we say it is a circumference, but either circumference or perimeter, both are the measurement of a length around the shape. So it's just outside, right? But area, when we're talking about area, it is inside. So I want you to compare area with perimeter. Okay. Usually we are using the units for perimeter as just a single unit. If it is an inch, it's an inch because it's a length, right? It's 5 inch, 7 centimeter, something like that. But if it is an area, it's inside. How much space is taken up in that space, in that shape, is area. So we are calculating that as how many square meter or how many square unit, how many squares can fill in to fill up that space, to fill up that shape is called area. So we usually use square units. Okay. So here is one tool that we use a lot of times when we are teaching area for elementary and middle school. We use GeoBoard a lot of times. I don't know how familiar you are with the GeoBoard. GeoBoard is very powerful tool. There are also virtual GeoBoard available too. I'm gonna show you that a little bit later too. Okay, so these are the elastic rubber band stuff. And we can make a lot of different shapes, right? One question you can ask is to find the perimeter around this weird shape. Or you can also ask how many square units it's taking. So you can ask area for each of these different shapes. In this, I gave you the tip here. So 1 square is 1 square unit. We don't know whether this is an inch or centimeter or whatever other unit it is. So we just use unit. Then this is 1 unit, that's 1 unit, and this square is 1 square unit to show this much space in the shape, right? Then a triangle like this will be half of it. So it is half of a square unit. To calculate or to count how many square units there are, we can simply count. So I can count, let me see. Okay, this is 1 square unit, another square unit, 2, 3, 4, 5, 6. This is half, and together it is another one, 7.5. So the first one, I know that there is 7.1/2 square unit. I want you to pause the video and calculate how many square units you can see on B and C. Okay, how did you do? Well, sometimes students can confused about this shape because they can see, oh, this is a square, so maybe that's a square unit, and that's a square, and that's a square. All of these are squares, so they see there are 5 square units. But is it true? Not really, right? Because our square unit is smaller. This is our square unit. Then this is just half of a square unit. Then another half of square unit. So together, these two triangles together makes 1 square unit. So in this big square, I have 2 square units, right? And I have 5 of those. Each has 2 square units, 2 square units. So I actually have 10 square units. Make sense? How about this one? Well, there should be several ways to calculate and to count how many square units there are, but I'm gonna look at what's inside here. I see 4 square units, right? 1, 2, 3, 4 square units. And together these two makes 1. Together these two makes 1. Together these two make 1. Together these two make 1. So I have 4, 5, 6, 7, 8 square units. Are we good? Okay, now I want you guys to think about making following the figures: a square with an area of 4 square units and an isosceles triangle with an area of 4 square units. In order to do these, you need to understand the definition of a square and isosceles triangle. What does a square mean? What does isosceles triangle mean? So square is a unique rectangle, and it is also parallelogram too. Square is a rectangle because square has to have all 90 degrees angle, right? Or on all 4 corners. So all 4 corners are 90-degree angle. And also it is a rhombus because it has to be all 4 sides congruent. Congruent means the same length. Right? So square is a very specific quadrilateral with 4 equal angles and 4 equal sides. We call that a square. So I want you guys to think about how you can make a square, 4 square units making a square, and that square needs to have 4 square units. And isosceles triangle, isosceles means iso means the same, isosceles means legs, so same legs. When you have 2 legs that are equal, we say that is isosceles triangle. The third one doesn't matter. It can be different from this or it can be the same. If it is the same length, so all 3 sides are the same, especially we call that equilateral triangle. Equal means equal, right? Lateral means length. Lateral. So specific case of isosceles triangle is equilateral triangle in which all 3 sides are congruent. But either case, both are isosceles triangles. Okay, so you need to have at least 2 sides congruent to make isosceles triangle. And pause the video and think about using this geoboard. So click geoboard and you can find something like this. Let me see if I can change the video. So this is a geoboard, and you can find different colors of rubber band. This is very powerful. So go to apps.mathlearningcenter.org/geoboard/. Okay, the first task that you need to do is to make a square with an area of 4 square units. You need to make a square. So my favorite, yellow color. If I connect these two, I know one side is 1, and if I put another rubber band here, oopsie, I will just take it out. This is a triangle, but I can stretch it. So this is 1 square unit, but I need to have 4 square units, right? So I can do 2 by 2 square. Then I have a square because they are all 4 90-degree angles, and all 4 lengths are equal by 2 units, 2 units, 2 units, and 2 units, right? And I have 1 square unit, 2 square unit, 3 square units, 4 square units. So this is good, right? Okay, now next one that you need to do is an isosceles triangle with an area of 4 square units again. So if I start with, let's say 2 as the width, and I can make an isosceles triangle. So this is an isosceles triangle, isosceles triangle, and so on and so on, right? This is not. This is a scalene triangle in which all three sides are different. If I draw, this is still just isosceles triangle, right? Not equilateral triangle. But anyways, we can think about making 4 square units. This is way too big because I see already here is 1 square unit, 2, 3, 4 square units. So I need to make it smaller. If I do it this way, it is still isosceles triangle because this length and that length is equal. But how do I count 4 square units? Let me use this pen. So I know this side, I can make a half of it, and on the left and right hand they are congruent, right? And I can see I need this much more to make 1 square unit, right? And that is exactly same area of this one. So together this and that makes 1 square unit. And similarly, I know this and that together, if I flip it over, it comes here, right? These two are exactly the same thing. So together, this makes another square unit. So in this half of an isosceles triangle, I have 1 square unit here and 2 square units. Then together, I can make 4 square units, right? So something like this can be 4 square units of isosceles triangle. Convert units from US customary to metric or vice versa. We can also talk about the areas, units of area, converting the systems too. So in this example, I put 1 feet by 1 feet square. So that is 1 feet square unit, right? Our unit is becoming foot in this case. So 1 by 1 is 1, and see, foot times foot is foot squared. So it makes sense, right? And we also know how to convert foot to inches in length. 1 foot is 12 inches and another 1 foot is also 12 inches. So you can convert each of them to the inches. And when you're multiplying them together, it's 12 times 12, 144, inch times inch, inch square. That's exactly same as 1 foot square. And I want you to compare this. So when you are given a length, 1 foot is equal to 12 inches. So it has 1 to 12 ratio. When you are changing that to square, so 1 foot square, that is equal to 144 inches square. What do you notice? It is square of 12, right? So when you are converting the area, you need to think about the ratio as a square unit. Same here. If you are given 1 yard, so 1 foot times 1 foot, 1 foot plus 1 foot plus 1 foot is 1 yard. Remember that 3 lizard is same as 1 boa constrictor, right? So we have 1 yard by 1 yard. In that, how many square feet are there? We know that 1 yard is 3 square feet and another 1 yard is 3 square feet. 3 feet, right? So the area is 1, 2, 3, 4, 5, 6, 7, 8, 9 square feet. Again, you can see the relationship here. 1 yard is equal to 3 feet. If you are changing that to an area, 1 square yard, that is square of 3, right? 9 square feet. So you can see the relationship between the length and the area. Area you can always compare with squared feet or squared unit. Okay, so here is the converting units. You don't have to remember this because you can just simply look at the relationship in the length and square them to find the converted units for the area. So 1 yard is equal to 3 feet, then 1 square yard is equal to 9 square feet. 1 foot is equal to 12 inches, so 1 square feet should be 144 square inches. 1 mile is 5,280 feet. Then how about 1 mile squared? 1 mile squared will be square of 5,280, and again the unit should be squared feet, and so on and so on. Okay, so you don't have to remember this, just know the relationship there. Same for metric system. So 1 meter by 1 meter is 1 square meter, and we know that 1 meter is 100 centimeter. So if we are changing that to 100 centimeter, and the height is also 100 centimeter, so the area will be 100 times 100 square centimeter. 100 times 100, you have 4 zeros, which is 10,000 square centimeter. So it makes sense, right? When you're making it smaller, to make bigger unit, it also works. So knowing in 1 square meter, it is 1 meter to 1 meter. If we are changing that to kilometer, kilo is 1,000th of 1 meter. 1,000 times of 1 meter. So 1 meter is equal to 1,000th of a kilometer. So 1,000th of a kilometer times 1,000th of a kilometer, you're gonna have how many zeros? 1, 2, 3, 4, 5, 6. You're gonna move the decimal point to the left by 6, and you have 5 of zeros there. And the unit is kilometer square, right? So you don't have to remember everything, just know the relationship between the metric system of the length first. So between kilometer and meter, if you know that, you can think about square meter is square of that. Okay, so I'm not gonna make you remember, but just know the relationship. Now think about completing each of the following conversion. So 5 square centimeter is equal to what millimeter square? Let's think about it. What do we know about square centimeter and millimeter square? We know that 1 centimeter is equal to 10 millimeter. Then 1 square centimeter should be 10 times 10, 100 square millimeter squared. So there is relationship between 1 to 100 relationship. If we know 1 to 100 relationship, we can set it up. Now we are given 5 square centimeter, which is in the front, so you can put 5 square centimeter is equal to how many squared millimeter. You can set up a proportion like that, and we know that inner and outer, right? So outer 1 times x is 1x, and we have a square centimeter, and millimeters square millimeter is equal to inside 100 times 5, 500, and you have square millimeter, and you have square centimeter. But you have square centimeter on both sides, so you can divide both by square centimeter, both by square millimeter. So simply x is 500 millimeters squared millimeter, right? How about this one? Meter, squared meter, and squared kilometer. What's the relationship between kilometer and meter? We know that 1 kilometer is equal to 1,000 meter. Then, if you know this, you can change that to an area. 1 kilometer, squared kilometer is equal to square of this whole thing. 1,000 times 1,000, 100, no, 1 million, right? 1 million square meter. Then you can set up a proportion, and you are given 124 million. So we can set up 1 square kilometer to 1 million meter squared is equal to what is given to you first, squared meter, which is letter 1. So we don't know how many square kilometer it is. We are given 124 millimeter, million meter squared meter. You can ignore the units if you have the same order of square kilometer first and squared meter next, because it will be cancelled out. Okay, just like the previous one. So we know that we can do inner and outer again, and x times 1 million is equal to, I already cancelled all the units out. Okay, that is equal to 1 times 124 million. So 124 million. To solve for x, we can simply divide both sides by 1 million. So x is left on the left hand side, and on the right hand side all the millions are cancelled out, and leaving 124 over 1, or 124. What is the unit? Square kilometer. Okay, so we can also extend the notion to land measure. So land is pretty big, so we are using bigger unit such as air, hectare, kilometer, square kilometer. In English system, acre or square miles. The relationship is pretty the same, okay, as the previous one. So 1 acre is equivalent to 100 square meter, and 1 hectare is 100 times 1 acre, so 100 acre is 1 hectare, which is much bigger than acre, right? And 1 square kilometer is equal to 1 million square meter, because we already talked about 1 kilometer is equal to 1,000 meter. Then square of that will be 1 million square meter. And we know that 1 million square meter is 100 times more than this, right? So that is 100 times more than 1 hectare. Okay. In English, 1 acre is 4,840 square yards. You can always use this measurement table because you don't have to remember all of that. Who does, right? Just know how you can use the proportion to find the answer. So for example, a square field has a side of 400 meter, and you need to find an area of the field in hectare. Okay, so we need to find an area with a square. It looks like a square, so sometimes it helps you to draw the picture to understand what's going on. And it says a square field has a side of 400 meter. So I know this side is 400 and this side is 400. All of the four sides are 400 meter because it's a square. And to find the area, we can simply multiply these two, right? So 400 meter times 400 meter will be the area. And I have 160,000. So I have 1, 2, 3, 4 zeros, and I have 16 there. And meter times meter, square meter, right? But it is asking you to find the area in hectare. What do we know about hectare? It's equal to 10,000 square meters. So we know that 1 hectare is equal to 10,000 square meter. And we are given square meter. So the latter one is what is given to you in the proportion. We don't know how many hectare it is. So you can set it up like that. Hectare first and then square meter unit. Hectare first, square meter unit. Then you can do inner and outer by cancelling all the units out. X times 10,000. So 10,000x is equal to 1 times 160,000. It's always good to just keep the units there and then cancel them out to make sure you set up the equation, proportion equation correctly. Okay, and then divide both sides by 10,000 to solve for x. 10,000. So x is, all 4 zeros are gone, all 4 zeros are gone, and x is 16. What is our unit? X is our hectare, so it will be 16 hectare. The second question, a square field against square field has a side of 400 yards. Now instead of meter, you are given a square with 400 yards. And 400 yards. So we know that the area will be 400 times 400 yards times 400 yards, and that is 160,000. This time it is square yard. Now it says you need to find that as acres. And what do we know about yards and acre? We are given yards and acre relationship here. 1 acre is equal to 4,840 yards squared. So writing that down, 1 acre is equal to 4,840 square yards. Make sure you write the unit so you know what you have started first and next. And yours is given as square yards. You don't know how many airs it is, right? So x air is equal to 160,000 square yards. Again, you started with the airs, then start with the airs, then square yards and square yards. Then you can cancel them out, right? So inner and outer again. And 4,840 x is equal to 1 times 160,000. So x is, you can divide both sides by 4,840. 160,000 divided by 4,840. And if you use the calculator, that gives you about 33. And what's the unit? Acres. Oh, was it airs or acres? Oh, actually acres, sorry. So it is acres. Okay. All right, and let's continue to move on to the next one. Now we're gonna talk about area of polygons. So briefly, we're gonna talk a little bit about the polygons, okay? So earlier we talked about square, rectangle, parallelogram, and so on and so on. Those are the polygons with 4 sides. So if you have any 4 sides of the shape, and when they are closed, then it is called quadrilateral. So polygons, I need to think about polygons first. To be a shape, to be a polygon, polygons you need to have straight lines. So circle or cylinder, those are not polygons. So you need to have a straight line segment, and then it has to be also closed to be polygon. So very straight, straight line segments like this. I made a triangle. It is a polygon because I have 3 straight line segments and they are closed. But if I put it like this, it is not closed, it's open here, so it is not a polygon, right? You can have different shapes. So this is I can make quadrilateral. Let's see. Well, actually this is 5 sides. 1, 2, 3, 4, 5. So it is not quadrilateral. Has 5 sides. So it is polygon. I'm sorry. Pentagon, right? 5 sides is called pentagon. When I say pentagon, maybe you can think about regular pentagon. So I'm trying to make it bigger. What happened? Hold on. Okay, so when I say pentagon, you may think about the regular pentagon, such as this. right? So in DC there is a pentagon shape look like this. But pentagon doesn't necessarily to be shape of this. So this is a special case of a pentagon in which I should have used this one instead. Okay, like this. It's a pentagon. And this is also pentagon. Well, this is a special case of pentagon in which you have exactly the same size on all five, and their angles, inner angle, interior angles are all congruent too. So we call these as regular pentagon. But this is also pentagon because you have a 5 size. Okay, it doesn't have to be regular pentagon to be a pentagon. Okay, so triangles like this. Let me show you a triangle too. So this is a triangle, and in this case specifically, I have all 3 sides congruent and all 3 angles congruent. So it is regular triangle, or we have special name for triangle, equilateral triangle or equiangular triangle, right? But this is a triangle too, right? And scalene is a triangle too. So all of these shapes, if it is straight line and if it's closed, we call them polygons. So you can have 3 sides, you can have 4 sides, you can have 5 sides, and so on and so on. All of those are polygons, and especially when you have a 4-sided shape, we call them quadrilateral. Quadrilateral includes rectangle, square, parallelogram, trapezoid. You know, there are so many different names for that by the definition. So one of them is a rectangle. So rectangle, rect, angle, right? So rect means right angle. So all four angles, all four corners have to be 90-degree angle. Then it is rectangle. In rectangle, it is easy to draw, square units, how many square units there are. And we can count them to find the area, right? So here is an area of rectangle. This is by inches, and it says 3 inches, which means this will be 1 inch then. 1 inch, 1 inch, and 1 inch. And here, this is 1 inch, 1 inch, 1 inch, and you have 5 of them, right? So what is a square inches then? 1 by 1. This much will be square inches. And how many square inches are there? I have 3 rows and 5 columns. So 3 by 5 many square inches I have. So simply we can multiply height by base, or base times height. So in rectangle, you can see that area is base times height, or height times base. It works because multiplication, you can do the cumulative property. So simply you can multiply 3 inch times 5 inch. And you can have 15, what's the unit? Inch times inch, squared inch, right? How about here? We can do 4 times 0.2, right? No way, because we have different units. We need to have the same units. So you can either change centimeter to meter or meter to centimeter, okay? Usually it is easier to change bigger unit to smaller unit. So 1 meter to 100 centimeter. So we know that relationship of 1 meter is equal to 100 centimeter, right? So using that, then 0.2 meter should be 20 centimeter. Again, you can set up an proportional equation. 1 meter to 100 centimeter. Sometimes I skip this part, okay? How many meter to 20 centimeter? And you can do inner and outer. 100 times x is equal to 20. And to find x, you can divide both by 100 and find that is 0.2. So 0.2 meter is equal to 20 centimeter. Oh, I should have put 0.2 meter here and find x. Anyways, we can find this as 20 centimeter. Now we have 4 centimeter by 20 centimeter. Everything is in centimeters, so we can simply find how many square centimeters I have, right? I have 4 by 20. So 4 by 20 centimeters each is 80 square centimeter. Okay, now area of parallelogram. So parallelogram is another quadrilateral because you have 4 sides. What's the definition of parallelogram? You need to know. Okay, so parallelogram is a special quadrilateral in which you have both opposite sides exactly congruent and they are parallel. Okay, so both pairs have to be parallel, both opposite pairs. So this length and that length are not only congruent, but they have to be parallel. And this side AD and CB are congruent and they are parallel as well. Okay, so that is the definition of a parallelogram. Two opposite pairs, one pair and two pairs. Two opposite pairs are parallel. Okay, so to find the rule for area of a parallelogram, you can cut this parallelogram into perpendicular line here. So perpendicular means 90-degree angle. So if I connect D and a certain point with a 90-degree angle, let's say that as an E, then you can see this is 90-degree angle. If I move this here, because this is exactly same length as this one and they are parallel, the angle here is the same, right? So I can just move this to here and make a rectangle. So as you can see, if I cut this out and put it here, it's an area, it's a rectangle with DC and DE as my new height, right? So we can see that, then to find the area, you just need to know what the height is, because you already know the DC, the basis length. So DC times H will be your area of a parallelogram. So we're gonna have some examples of that. We'll come back to the triangle, okay? But first, do I have it? Here we go. Let's find the area of these two parallelograms. So in parallelogram, we know that the base is 16 centimeter, and you have height. Height is always perpendicular to the base from one corner. Okay, so it is 4. So if you think about cutting this and putting it here, it looks like this kind of rectangle, right? Because this is the same as this part. So I am actually finding an area of this rectangle. And we already know that this is 16, then this will be 16 as well, right? And our height is 4 centimeter. So it is 16 times 4 square centimeter. What is it? 4 times 6 is 24, 4 times 1 is 4, so 64 square centimeter, right? How about this one? This is shown a little bit differently, So in this case, we are given a base of 5 here. Instead of cutting it this way, you can cut this way too. So the base is 5, and the height is 8. So don't be confused with that and the base of 10. This height is a height of this base, right? So we can do base of 5 times height of 8, and both are in centimeters. So it will be 40 square centimeters. When you are looking at triangle, you can extend the idea of parallelogram. So if you are drawing a parallelogram using this triangle, so this line and that line is parallel, right? And I can make another parallel line to AC. So this and that is parallel. Oops. Okay, hold on. Keep it as it is. Okay, so I can draw a parallel line to AC, right? So we can draw a parallelogram here, and I see that this side and that side are not only parallel, but they are congruent, the same length, and same for this and that. And then I cut, diagonals here. Then I can make two exactly same size of triangle, one up here and one down here. So these two triangles should have the same size of area, right? But we know how to find the parallelogram. So if you know how to find the parallelogram, you can just cut it in half to find the area of only one triangle. We know the parallelogram we have B times H. That's the area of this big green parallelogram. But we are only concerned about 1/2 of it as a triangle. So we can do 1/2 of BH. Okay, that's how you are doing it. And you can also think about, folding the papers down too. So if you are folding in half of the height of a triangle, it looks like this, right? And then you can think about folding half of this triangle, right? So it's a half of it. And you can also fold this side, half of it. So everything is in half of this big triangle, but it looks like what? A rectangle with this times this. And we know that the height is 1/2 of 2, and this will be 1/2 of B, but we folded in half of everything. So to find the original size, that times 2, right? Then it gives us a triangle area as H times B or B times H, and half of that. So it is the same as 1/2 of BH. So triangle's area is 1/2 of base times height. Examples of area of triangles. Okay, so you are given several problems, and of course you can do 1/2 times base and the height. You need to determine with what is a base and what is height. Base and height, base can be always easily found, but height, if you chose AC, side AC as the base, the height has to be 90-degree angle perpendicular into the opposite corner here. So this will be 90-degree angle, and you define the length there. We sometimes call that as altitude too, right? So base is 10, and you have a height of 4 centimeter. So you can see that, well, this can be cancelled. 4 times 5 is 20. Unit is square centimeter. Okay, how about here? This is so simple too. Base is 5. And height is already given to you because it's rectangular. It is right angle here, and especially this is called right triangle because you have one right angle there. So it is 1/2 times 4 times 5 centimeter, and you can cancel this and you get 10 square centimeter. And here you are given altitude here because I see the 90-degree angle here. So the height is 4. Then this should be the opposite corner of this as the base. The base is only this much length. So you are given 2 centimeter. A lot of times you're going to be given all the length here, and you need to determine what is the base, okay, correctly. So this can be base in this specific case, and you can always extend that side to find what is 90-degree angle for the height. And the height is 4 centimeter. And you need to do half of that. So that will be 4 square centimeter. Pretty good, right? Okay. Oops. So we got all of that. And now let's talk about kite. What is kite in definition? So kite is also another quadrilateral because kite has 4 sides. Okay, parallelogram, you have 2 opposite sides, parallel and same length, right? So this is parallel and they are same length, and this side are parallel and they are equal for parallelogram. Okay, but for kite, not the opposite sides but adjacent sides, meaning they are connected. They share one vertex. So this side and that side are congruent. Okay, and this side and this side, they're adjacent at this point, right? They are congruent. Then we call this as a kite. So you can see that, oh, square then is a kite because this and that are congruent, sharing this corner. And sharing this corner, they are adjacent with this and that, and they are also congruent. So square is a kite as well. So square is everything. Square is parallelogram, square is a kite, square is also rectangle. Okay. So if you are given a kite like this, you can see how I can dissect them. Meaning, so this diagonal here, let me use different color. So I can have one diagonal here and there's another diagonal, and the diagonals are perpendicular to each other. So then if I cut them all out and rearrange them, I can make a rectangle because this 2 here is 90 degree, this is 90 degree angle, this is 90 degree angle, this is 90 degree angle. All of these corners are 90 degree angle, and each of the triangle then is right triangle. So one here you have 90 degree, 90 degree, 90 degree, and 90 degree angle. So putting them together, you can make a rectangle like that, right? And that is giving you the length here. This is first diagonal here because you see that this side is the same as this side, and that side is the same as this side. So together it's diagonal 1. And diagonal 2, you can look at this from that triangle is the same length as this yellow triangle's length because it's sharing, right? So that is exactly same as this length and that length. So we know that we can cut them out and using the diagonals. That's why we put D for diagonal. This diagonal times that diagonal will give you the area of this rectangle. Where if you rearrange them, it is the same as a kite. So the area of kite will be diagonal 1 times diagonal 2. Diagonal 1 times diagonal 2. Diagonal 2 is this much length. So only half of that, right? So half of that. Okay, so that is the area of a kite. Then let's think about some examples here. Okay, this is not a kite. This is called a trapezoid. Oh, did we talk about trapezoid yet? We were supposed to. Okay, let's look at some trapezoid first. There we go. I skipped it by an accident. Okay, so trapezoid is quadrilateral again, and definition of a trapezoid is at least one pair of opposite sides are parallel. Okay, so for This trapezoid, I want you to pay attention to one trapezoid. You can see that this side and that side are not congruent, but they are parallel. So at least one pair of opposite sides are parallel, then it is trapezoid. Then you can see that, oh, parallelogram has two pairs of parallel opposite sides. These two are opposite and parallel, and these are also parallel to each other, right? So it is also trapezoid. Okay, it's also trapezoid. But most of the time it shows like picture like this in the poster. But remember, this is also trapezoid. Okay, in trapezoid, we know that these two are parallel, B1 and B2, but different length. But if you are drawing exactly same thing upside down, because these two are parallel, these are parallel, and you can have the same length here, and I'm gonna have exactly parallel to that one. Then I can make two trapezoid combining by one parallelogram with a height of h. Okay, think about the area of a parallelogram. You need to have a base times height. Base times height. Right? So if we are thinking about this big parallelogram, which is double of trapezoid, we know that B1 plus B2 is the base. And then height is h. So base times h will be an area of this parallelogram. But our trapezoid is only 1/2 of that. Right? So you can do 1/2 of that. That is area of trapezoid. Okay? So that's how you get the formula for that. Now we can solve a lot of different problems there. Oh, hold on. We didn't do the area of a kite. It is, I guess it will be shown up later. Okay, so let's look at this example, trapezoid. Pause the video again and think about how you're gonna solve the problems, okay? First. Okay, you got that? Alright, find the areas of trapezoid. How do we find trapezoid? You can think about drawing another exactly same size of a trapezoid. So you're gonna have I'm not good at drawing, right? So these are parallel continuously, and this and that are also parallel and congruent too. So you can see that this trapezoid and that trapezoid is exactly same. So you're gonna have a parallelogram, and half of that will be trapezoid. So 1/2 of this trapezoid length. This is 16, and then this is also 16, because these two are exactly same thing, just upside down, and this will be 12 centimeter, right? So base will be 16 plus 12 centimeter, and the height is 4 centimeter. And you are taking only half of that parallelogram, so we're going to take half of that, which is 1/2 of 16 plus 12, 28 times 4. If we are taking half of that, it will be 1656. What is the unit? Square centimeter. Right? How about this one? There are several ways. You can see this is a trapezoid, or you can think about, oh, these two are exactly same triangle with a 45-degree angle, and this is 45 and this is 90-degree angle. So maybe you can cut this and put it here, right? And see that, oh, it is a rectangle. This whole thing is a rectangle, right? And this is 2 centimeter. And if this is 45 degrees, we know that triangle, the sum of interior angle is 90. So the other part here will be also 45-degree angle. That means this triangle here and this triangle here is isosceles triangle. So the length here and the length here are congruent. So if this is h, then this should be h too. So this is h. And of course, this is 2 centimeter. Are we good? Okay, so we have one square here which combining these two triangles. So I have h squared and I have 2 times h, 2h, both are square centimeters. So this will be my area. But can we find h? Yes, we can, because we are given 8 centimeter here. Oops, this is not, yeah, this is 2 centimeter. Okay, so if you are given total 8 centimeter and we know this is 2 centimeter, then h plus h, the other 2 should be 6. So 6 plus 2 makes 8. Then each of h should be 3 centimeters, right? So our h is 3. Then you have 3 squared plus 2 times 3 square centimeter, which is 9 plus 6 square centimeter. That is 15 square centimeter. My room is so noisy. It's so noisy. Sorry about that. I don't know what's going on here. Okay, so those are the areas of trapezoid and all the quadrilaterals. Now you can extend this notion to other polygons. So here are some regular polygons, equilateral triangles. So regular polygons are special polygon with all sides congruent. So these 3 sides are congruent. So this triangle is regular polygon. We have special name equilateral triangle, and this is a quadrilateral because you have 4 sides. But if it is regular quadrilateral, it is a square. 4 sides are congruent and all 4 angles are congruent. From then on, you can just name it. 5 sides pentagon, 6 sides hexagon, 7 sides heptagon. You cannot see that very well, but it's heptagon. Okay, 8 sides octagon, 9 sides nonagon, and so on and so on. Okay, 10 decagon, 12 dodecagon, and so on. So you can see all of these sides are congruent, right? Then we say it is regular polygon. Otherwise, it's irregular polygon. But anyways, if you are given a regular polygon, you can easily find the area. Because we already know for triangle and quadrilateral came from 2 triangles too. So thinking about that, we can easily make a lot of triangles for every regular polygons. Here are in pentagon, we have 5 equal size triangles. So you just need to know the base, which is same length for all around, and find the height. Find the height. So let's say this is A times H times 1/2 to find the one triangle's area and multiply that by 1, 2, 3, 4, 5, right? Same for hexagon. If you know the length here, and you can make triangles, 6 of them, 6 of triangles for hexagon. You just need to know what the height is for each triangle. So 1/2 times A times H, and you multiply them by 6. For every regular polygon, you can do that, right? So for example, if you are given a hexagon here, and you are given one side length is 10 centimeter, then we know that because it's a regular polygon, every side it is 10, 10, 10, 10. And if you are making a triangle here, if you are making a triangle, it is isosceles. Well, I cannot do that well. Okay, let's try that again. So if you connect, oh, it's better. Not really. Okay, please understand what I'm doing here. So I could draw an isosceles triangle, right? In which this side and that side are congruent. And we know that the height here is given to you as 5 square root of 3. So we can find the area of this triangle. This triangle's area is 1/2 times base times height, right? And how many do I have? I have 6 of them because it's hexagon. 1, 2, 3, 4, 5, 6. So you can just multiply this by 6. Okay, now you can do some calculation. In multiplication, I can use the commutative properties. I can do 1/2 times 6, which is 3. 3 times 5 times 10, 150 square root of 3. What's the unit? Square centimeter. So simple, right? Okay, now we can move to a circle. Circle is not a pentagon, right? Pentagon has straight line segments and it has to be closed. Circle is closed but doesn't have straight line segment. So it is a special case. It's not a polygon, but it is a circle. What's the definition of a circle? From one point, all equal length. Oops, sorry. Yeah. Hold on, let me do that again. Accidentally, I drew a triangle, but I'm going to draw a circle. So the definition of a circle is, hold on. So something like this. These are the circles. But whenever I draw a circle, what happens? There is a center, right? So let me bring that down here. Oops. Let me bring down that. Okay, let me draw another circle here. So here is another circle, and I'm pretty sure you have noticed that there was a center. So from the center to all of those points on the circle has the same length. That's how we are using the compass, right? To draw a circle, you're using the compass. Fixing that point center, and you have the same length, and all around you're making a circle, right? So we call this as a radius. So we have equidistance between the center to all the points, then we make a circle. And I'm gonna show you this interactive tool quickly. This is a GeoGebra again. This is a pretty cool tool, so I want you guys to use this when you're teaching circle. So in this circle, I have a half of a circle in blue and half of a circle in red, right? So what is the circumference in the length of a circle? Is 2 pi r. So if I take only half of it, the red part here will be pi r, right? Half of 2 pi r is pi r. So the length here is pi r, and the height here is the same as the radius. So I put r there, right? And what I'm going to do is I'm gonna cut this circle in half and open them up by these sectors. So as you can see, I can move this down here, and I can unfold the circle up, and it looks like this, right? It's not exactly a rectangular shape yet, but we can see that, oh, it is pretty close to pi r of the base and height of r, right? But if I cut more slices of a circle, so I'm gonna go back and I'm gonna show you more slices like this. Compare that with the previous one. I still have a pi r here and r here because I have half of circumference and radius, right? But if I move them down there and unfold the circle, look at this. It's very close to a rectangle with pi r times r as the area, right? So if we cut them really tiny pieces, it is getting closer and closer to pi r times r, right? So we can come to a conclusion. Our area of a circle is pi r times r. Simply, we can do pi r squared. you can come to a conclusion here. Area is pi r squared. Then let's think about some sectors of area of a circle. So if you are given a circle and you are, cutting them into pieces, then we call them sectors. So some sectors you can have 90-degree angle. Now, if it's 90-degree angle, it's easy because you can see that it's just 1/4 of that. So for this one, it is 1/4 of a total area pi r squared, right? But you're not always given 90-degree angle. You can have different angles. So for example, if you are given theta angle, well, any angle, okay, then what do? We can think about the relationship. So proportion comes to play here again. We know that pi r squared is a circle, the total circle's area, with 360 degrees for total circle, right? So compare that with 360-degree angle. And the proportion for different angle, not 360 angle. What if we are given theta angle? So you start with angle first. Then what is the area? This is an area of 360-degree circle. Then what is the sector's area when theta angle is given to you? We can do the similar, proportion equation here. So inner and outer, and I have 360 degree times x as the area. This is area, and this is area of a circle, right? This is area of a sector. Inside, I have a pi r squared times theta. So theta times pi r squared, or pi r squared times theta. And of course, I have angle there. So I can divide both sides by angles. And I see 360 is multiplied by x, so I can divide both sides by 360. Then what is x? My area of a sector is theta divided by 360, and I have pi r squared. You can keep pi r squared in the numerator, or just like this one, you can separate them. Pi over 360 times pi r squared. Make sure it is in the numerator, okay? So that is how you are finding the area of a sector. If you want to remember this rule, you can go ahead. I don't remember that. I usually use the proportion because it makes more sense to me. So you choose, okay? And here is an example. Find the area of a red sector below. So again, I don't remember the rule, so I'm going to use my reasoning here. I know if it is a circle, it's 360 degrees, and the area is pi r squared. Pi r, in our case, is 3 inches squared. But I have given only 64 degrees of angle instead of 360, so 64 degrees to what the area of the sector is. And then I can do inner and outer. Outside, I have 360, x is equal to 3 squared pi, which is 9 pi times 64. Right? And then I can divide both sides by 360 to find the sector's area. So x is 9 pi times 64 over 360. Instead of multiplying them together, I'm gonna simplify that already. So both are divisible by 9, 40, and both of these are divisible by 8. 8, right? So I have 8 times pi, 8 pi over 5. This is good enough for me, okay? Or you can just use your calculator to calculate pi with 3.1 for dot 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 to be exact. That's also good. Alright, what is the unit here? It's an area, so you need to have square inches. Okay, now we are gonna finalize this section by working on some other shapes. So like yin yang symbol, I am looking at this, and I want you guys to pause the video to think about these area questions too. And I see that, oh, this is a half of a circle with the same size of a half of a circle here. So if I cross that out and put it here, it's gonna be just half of this circle, right? So half of this circle. And I see that the diameter of this big half of a circle is, if this much is 1 centimeter, the radius here will be 2 centimeter. So I know that I'm gonna take pi r squared, where r is 2 centimeter, right? But I'm gonna take only half of it, so 1/2 of that. And the unit is, of course, squared centimeter. So I have one of them gone, 2 pi square centimeter, right? And here is another shape. I want you guys to think about this question by considering how you're gonna solve the problem first before I go into. You got that? What is your idea? Maybe yours is different from mine. But what I see, this square is, I see that this leaf looks like clover, but this is 1/4 of this big square, and the leaf here is the same size for all 4 leaves. So I'm gonna find what area for this one is, and then multiply that by 4. Does that sound like a plan? So I'm gonna do 4 times this shape. To find the area of this kind of shape, or 4, I'm looking at the first one here and see it is easily found, the sector here area, because it's 1/4 of this big circle, right? And then I know how to take out, this triangle. So what I'm saying here is, I am looking at one of the 4th square, and I see this much is 1/4 of a circle with radius of, what is radius? It's half of 10, so 5 centimeter. So radius of 5 centimeter. I'm looking at 1/4 of the circle with radius of 4. And then I'm going to take away this triangle to leave only this shaded part, right? So if I take away that triangle, then I'm going to leave only half of a leaf, right? And then I'm gonna multiply that by 2 to find 1, and multiply that by 4 to find all the area. Or I can just simply multiply this whole thing, this by 8, because I have 8 of those. 2, 4, 6, 8, right? So that's my plan. So I'm going to do 8 times this. Make sense? Okay, so you need to help me out with that. So how do I find the area of this sector? It is 1/4 of this circle with radius of 5, because this is 1/4 of circle like this, right? So 1/4 of pi r is 5 squared, and I have 25 pi over 4. But I need to take away the triangle with 5 as the length here, and it is half of a square, so this side is also 5. So it is isosceles triangle with a 90-degree angle, right? And base is 5, height is 5. So triangle, you can do half of base times height. So total, I have 25 pi over 4 minus 5 times 5, 25 over 2. That is only the half of the lip, and I have 8 of those half of the lip. So area is equal to this whole thing times 8. then I can just multiply 8 by 25 pi over 4 minus 25 over 2. So I can distribute 8 to each of them. Then I get 4 times 1, 4 times 2, 2 times 25, 50 pi. And 2 times 1, 2 times 4, 4 times 25, 100. This will be my area for these green leaves. And what is my unit? Square centimeter. Okay? And lastly, we're gonna do some proportion. We already have talked about that. But when you are given the similar figures, for example, these two triangles are similar because it's just blown up or shrunk without changing the angle. Only the length are changed, but the ratio is exactly the same. So B became B1 and C became C1, A became A1 and H became H1. We are shrinking the size proportionally. Nothing else has changed. So for example, the ratio is like 2 to 1 for the length. Then what happens to the area? It will be 4 to 1 because area you need to do square of everything, right? That's all that matters. Okay, so one example. What did I had an example? Did I think I skipped. Down here. Okay, so for a similar polygon with a scalar factor k, if the factor is a k, which is the ratio, then ratio of their areas is k squared. So we're gonna look at the example here. Is it true that the viewing R of a 35-inch flat screen is about twice the viewing area of a 25-inch square flat screen? So we are looking at rectangular screen, right? So let's say you have a TV screen, and first one is area of 35 inches. The area, sorry, I misunderstood. Okay, it's not area, it says 35-inch flat screen. So you know, in flat screen we are looking at the diagonal, right, as the inches. So 35-inch flat screen is about twice of the viewing area of 25-inch square. We're gonna compare that with 25-inch square. So what is the ratio between these two? It's 35 to 25 in length. If we want to simplify this, it is both are divisible by 5, so it is 7 to 5 ratio, right? But if we are taking the area, it will be squared, right? So area then should be 7 squared to 5 squared ratio. So it will be what? 7 squared, 49 to 5 squared, 25 is the ratio. So can we say it is about twice the viewing? I would say yes, because twice of 25 is about 50, right? Even if 35 is not twice of 25, twice of 25 is 50 inches, right? But the area is about twice. So that's that. That's the end of this section. So if you have any question, please let me know.